Alright guys, today we are looking at order of operations. Now you probably looked at this a bit last year, but we're going to look at it even more closely this year. There's a specific order that you have to do operations in when you're simplifying numerical expressions into a single quantity, evaluating them. That order we usually abbreviate with the acronym PEMDAS. Okay, and people use all sorts of mnemonic devices to remember those letters and then go back and try to remember what they mean. Please excuse my dear Aunt Sally is the most common one, but maybe see if you can come up with one of your own that might be a little bit easier, especially if you don't have an Aunt Sally. It might not mean a whole lot to you. But what do those letters actually stand for in terms of order of operations? Well, the P stands for parentheses, but it also stands for any other symbols of inclusion. Okay, so that's really massively important. Because what are some other symbols of inclusion? Well, those could be brackets, absolute values we're going to work with later on in this class. So, you're going to want to be familiar with those. It also means the fraction bar. The fraction bar is a symbol of inclusion. Basically what that would mean as far as order of operations is you have to simplify the numerator and denominator of your fraction first in terms of order of operations. The E stands for exponents. M and D, I hope those are self-explanatory, multiplication, division. A and S, addition and subtraction. The other thing that's really important is that the order of operations is really P, E, M, D, A, S. Okay, so the thing is, when you get to the multiplication and division, you actually do that all in one step, but you do that from left to right. So if you have lots of multiplication and division in a problem, you're going to work it all out, and you're going to do it from left to right. Same thing with the addition and subtraction. After all your multiplication and division is gone, then you do your addition and subtraction and you do it from left to right. Now, here's a question that I've asked classes before. Can you prove that this order is correct? How could you actually prove it? Okay, because this order didn't come from nowhere. It's not as if this was just something we all agreed, hey, let's make sure that we're all using the same order, okay? It's not that. This is the order that it has to be. So one of the things that I want you to think a little bit about is how could you actually prove that it's correct? Okay, now a lot of people have told me, well, I would just do it the other way and I'd see that it's wrong. But again, how do you know that that's wrong? That's where it does get a little bit tricky. So maybe that's something that you could discuss in your groups. It is something that we can discuss in class together if you'd like to. But think about that. This is something that I would definitely like you to discuss in your groups at some point. I think it would be a really good thing for you guys to discuss. Okay, moving on though. Let's get some practice. Okay. So, I usually, when I'm doing an order of operations problem, especially if I'm out of practice, we just had summer, I'm a little out of practice, I'm going to write PEMDAS right on there, just so I don't forget. Okay, in this first one, A, I don't see any parentheses, I don't see any exponents, so I'm on to multiplication and division, so I need to do the multiplication first. The 34 stays, the subtraction sign stays, and I transform my 4 times 2 into 8. I have no more multiplication and division. I'm on to addition and subtraction. 34 minus 8 is 26. Always circle or box your answers. That's just a good habit to get into. Helps when you're checking work too. All right, B is a little bit more complicated. I'll still do this one, and maybe all of you guys practice some of the next ones. So here, I do see parentheses. So that means I need to simplify this down just to one number first. And I still need to follow order of operations in there. So I need to do 6 divided by 2 first and get 3, and then I need to do 5 plus 3, which is 8. So now I've got 60 minus 7 times 8, okay? When you see a 7 or any kind of number and then parentheses, we're going to assume that that's multiplication in between there, and then plus 2 to the 4th. Now I see exponents. Again, you see I didn't do the exponent first because they weren't inside parentheses. Now that my parentheses are gone, I can do the exponent. 2 to the 4th is 16. I'm going to kind of bring this up over here. Next would be multiplication and division. 7 times 8 is 56. Now, I want to be very careful. I do want to add and subtract from left to right. I should not be doing this first. No, don't do that first. Okay, you want to work from left to right. 60 minus 56 is 4. And then 4 plus 16 is 20. And you could do that last bit all in one step if possible. Okay, taking a look at what we got next. Why don't you guys try C and D on your own, pause, and then come back and we'll do a reveal. Okay? All right, I'm assuming you have now tried the problems, paused and unpaused, and you're ready to see the answer. All right, C. Remember I said that the fraction bar is a symbol of inclusion? All that means is we need to assume that our numerator's in parentheses and our denominator's in parentheses. We need to do each of those first and follow order of operations. Okay, so in my numerator, I need to do my exponent first and get 16. Then I need to do my multiplication. Then I need to do my subtraction. In my denominator, there's no exponent, so I can just do my multiplication there first. And 13 minus 6 is 7. So I'm just going to bring that 7 all the way over. Now I can do 28 over 7, or 28 divided by 7. That's 4. Hopefully you got that one right. D, when I have multiple symbols of inclusion like inside of each other, well, think about what that means. I need to take care of this entire thing before I do 6 times it. And within there, I have to do this first because that's a symbol of inclusion. So I'm going to do the 2 plus 1 first. So I have 6 times 1 plus 2 times 3. Once you've used a symbol of inclusion, like that 2 plus 1 was in parentheses, you don't need to rewrite the parentheses. That is unnecessary. Next, I need to follow order of operations in here. Oops, sorry about that. And I get 1 plus 6. Then I get 6 times 7, which is 42. So hopefully you got both of those right. That's our basic practice with order of operations. It can get a little more complicated than that, but for the most part, that's really it. You just want to make sure that you're following order of operations, and the biggest thing is don't forget to follow order of operation inside parentheses and other symbols of inclusion. That's really important too. That's it for today. Hope you learned something.